Modern chemistry is based on Dalton's atomic theory, proposed in 1808. Elements are composed of extremely small particles called atoms. All atoms are identical, having the same size, mass, and chemical properties. Compounds are composed of atoms of more than one element. In any compound, the ratio of the numbers of atoms of any two of the elements present is either an integer or a simple fraction. A chemical reaction involves only the separation, combination, or rearrangement of atoms. It does not result in their creation or destruction. Here's a picture of J.J. Thomson with a cathode ray tube. He measured the charge to mass ratio of the electron to be 1.76 times 10 to the 8th coulombs per gram. Here's a modern cathode ray tube. It shows a beam of electrons that is being deflected by a magnet. It can be deflected towards the positive pole or towards the negative pole. Robert Millikan's experiment determined the mass of the electron. Knowing the charge and Thomson's charge to mass of the electron, he was able to calculate the electron mass as 9.10 times 10 to the minus 28th grams, which is extremely small. Ernest Rutherford discovered three types of radiation: alpha particles, beta particles, and gamma rays. Look at the experiment below. The radioactive substance emits a beam that is passed through two electrically charged plates. The beta rays are deflected towards the positive plate, meaning that they are negative. The alpha rays are deflected towards the negative plate, meaning that they are positively charged. Gamma rays carry no charge and hence go straight through. Here's a rudimentary picture of the atom that Thomson proposed. He knew that at this point the electrons were outside of the atom. Ernest Rutherford performed another experiment where he took an alpha particle emitter and shot it at a piece of gold foil. The atoms of gold deflected the alpha particles in many different directions. Since alpha particles are positively charged, he theorized that the nucleus of the atom must contain positively charged particles. His conclusions are: atoms' positive charge is concentrated in the nucleus. Protons have the opposite charge of the electron, and also that the mass of the proton is 1840 times the mass of the electron. Rutherford further proposed that the atom was like a planet, with the nucleus in the center and the electrons orbiting around like the moon around the Earth. The atomic radius is around 100 picometers. The nuclear radius is 5 times 10 to the minus 3 picometers, much smaller. Chadwick furthered the experiments determining what was inside the nucleus of atoms. He knew that hydrogen atoms had 1 proton and helium atoms had 2 protons. Therefore, the mass of helium divided by the mass of hydrogen should equal 2. But when he measured it, the mass of helium divided by the mass of hydrogen was equal to 4. What could account for the difference? He proposed that there were neutrally charged particles in the nucleus, which he named the neutron. The neutron mass is roughly the same as the proton mass, 1.67 times 10 to the minus 24 grams. Here's a summary of what we know about subatomic particles to this point. Protons and electrons are the only particles that have charge. Protons and neutrons have essentially the same mass, and the mass of the electron is so small it can be ignored. Atomic number is given the symbol Z. It is the number of protons in the nucleus. The mass number is given the symbol A. It is the number of protons plus the number of neutrons in the nucleus. Isotopes are atoms of the same element with different numbers of neutrons in their nuclei. The element symbol is X, the mass number is A, and Z is the atomic number. Here are 3 isotopes of hydrogen: protium, deuterium, and tritium. 2 isotopes of uranium. It's a picture of the isotopes of hydrogen, showing the 1 proton in protium, the 1 proton and 1 neutron in deuterium, and the 1 proton and 2 neutrons in tritium. Tritium is also radioactive.